In this video, we'll practice identifying the function family of a graph, equation, or word problem, and we'll practice identifying which function family that one of those things belongs to. We will also practice identifying the domain and range of a graph. So on this slide, our goal is to look at each graph and decide which family of functions it belongs to, and then identify its domain and its range. So to start, let's write out our 4 different types. So we have constant, we have linear, we have the absolute value, and we have the quadratic. And what I like to do is make a note of what these shapes look like. So I know the constant is a horizontal line, linear is going to be some sort of diagonal or vertical line, absolute value has a V shape, and quadratic has a U shape. So when I look down below, what I notice is that graph number 3 has a U shape. So I know that this has to be of the type quadratic because it has the same shape as that quadratic parent function. Then when I take a look at number 1, I notice it has the V shape, so I know that this one has to be an absolute value because, again, it has that same shape as the absolute value parent function. And then thirdly, number 2 in the middle, this one is a line, so it has to be one of these two, constant or linear, and because it's not a horizontal line but instead is a diagonal line, I know that this is a linear function. So I've identified which family of function each of these belongs to. Then my goal is to determine the domain and the range. And when I look at each of these graphs, so I look at this absolute value graph, and I'm going to focus on domain first here, what I notice is this graph goes forever to the right and forever to the left. Because I am using all x values, both to the right and to the left, I need every single x value to make points on that graph. And as a result, my domain is going to be all real numbers because I need all x values, both left and right. When I look at graphs 2 and 3, I notice the same thing. This one, even though it's a diagonal line, it is going forever to the right and forever to the left as well, which means my domain is, again, all real numbers. And the quadratic graph, again, while it's a U shape, is still going forever to the left and forever to the right in some way, and I still need all x values, so the domain of that graph is also all real numbers. Now where this is going to differ is when it comes to the range. So the range represents all of the possible y values that are needed to make a graph. If I look at this absolute value graph, what I notice is that this graph doesn't go below -3. If I look at this entire space down here, what I notice is the graph doesn't go down here. So what that means is that we have a restricted range. So our range isn't all real numbers. Instead, it's only a specific subset of numbers. And if I look closely, what I notice is that my range starts at -3 and it goes up. It contains all of the values of y that are above -3. So my way of representing that is I write y must be greater than or equal to -3. And this states that -3 is an important key value when dealing with range, and my range is going to go above -3. Now if I look at the linear graph, what I notice is this graph goes forever up and forever down. So what that means is my range is all real numbers. And then if I look at the quadratic graph, I notice that this one has a high point of 5. It doesn't go above 5. It's 5 or below, and I can represent that by using y is less than or equal to 5. I'm saying I take all of the y values at 5 and below, and those will create points on my graph. So on this slide, what we're going to do is we're going to determine the family of functions each of these belongs to. And what I like to do is I like to write out my 4 parent functions. So I have the constant function, which is f of x is equal to 1. I have the linear function, which is f of x is equal to x. I have the absolute value function, which is f of x is equal to the absolute value of x, and then I have the quadratic function, which is f of x is equal to x squared. So what I'm going to do here is I'm going to essentially look for similarities between the equations in the problems down below and the parent function. And if I start looking, what I immediately notice off the bat is that in problem number 1 and in problem number 6, I see that I have the squared function somewhere around this x value. This squared function is only found in the quadratic function. That is why it is a quadratic, because its highest power of x is a squared. So if you see a squared contained in a function anywhere around x, you can automatically assume and note that these are going to be quadratic functions, and they will have that parabola shape. Then from here, the second thing I notice is that two of these problems have the absolute value symbol with an x on the inside. The only types of functions that have absolute values around x are the absolute value function. We can see that here. So because these contain an absolute value with an x on the inside, we can assume these are absolute value functions. Now, when I look at problem number 4, what I notice is that this one has no x and just has a number. Again, because it has something in common with one of these parent functions, in this case the constant function doesn't have an x value, it only has a number, this is going to be a constant function. And then finally number 3, if we take a look at that more closely, we see that this one doesn't contain a absolute value, it doesn't contain a squared, and it contains an x, so it can't be a constant function. Because this just has x and numbers involved in it, this is going to be your linear function. So you can take those context clues out of the equation and identify which family of function it belongs to.